All right, just because I need the practice, we're going to do number 3. That was the funny thing about that statement, is that this will be the 4th time I've done it. But that tells me also it's a good problem. You know, if all 4 classes ask for it, that tells me, hey, that was a good problem to pick, to put in there. Possible. Well, don't forget the in-class problem would cover things in accelerated motion and friction, and also this pulley. So it could be this WebAssign or WebAssign Forces 3. So, all right. Tell me something about that you know about tension in a cord. Okay, it would be a force, so it'd be newtons. What else? Okay, that's a good point. Can't be negative. Anybody else know anything about tension in a cord?
It's tighter the more you pull apart.
Okay, goes in one direction. How does it compare in different parts of the cord? Same direction and the same magnitude. So we've got this one really big long cord here, right? Goes from here, it goes down, it goes around, it goes down. So if I was to measure the tension in the cord right here, and I found it to be, say, 200 newtons, what would it be here? What would it be here? Here. 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 200 newtons, the whole cord, right? So look what that tells you. That says F is the same as FT1. That's T. Is the same as FT2. So 3 of my answers are going to be the exact same answer. That's pretty cool, right? Okay, so let's see. Let's think about some tensions. Well, the rope would pull down like that. It would pull up like that, and up like that, and down like that, and down like that. And all of those are going to be the same. So I'm going to, because they're on the same cord, that green cord, I'm going to label them all just F. All right? All 5 of those forces, because they're the same tension and they're in the same cord, are exactly the same. Yeah? That is kind of awesome. Now, if the pulleys weren't light, that wouldn't be true. But because the pulleys are light and frictionless, it's true. All right? Which leaves us with, well, there is some tension up here on the top that's different. We'll call that one FT3. And right, that would pull down on the ceiling, even though we're not worrying about the ceiling right now. And then that means that there's a force that pulls down on the bottom pulley, and that same tension, which we'll call FT4, pulls up on the piano. And then the piano, of course, has some amount of weight. What's another way we could write that weight? We haven't done it much. We've written it as F sub G most of the time. But what does F sub G equal? mg. So we could also write that as just mg instead, if we wanted to. Yes? Right? Does that make sense? So I'm going to need to do 3 free bodies here. I've got to do one for the piano, I got to do one for the lower pulley, and I need to do one for the upper pulley, because I need to know things from each of those. So, but the good news is they're not very complicated free bodies. So I will do the piano over here, I'll do the lower pulley here, and I'll do the upper pulley here. So, forces on the piano. I have its weight down, which we're just going to call mg this time. It has FT4 up. What's the acceleration of my whole kit and caboodle here? Nothing. 0, right? No acceleration. That's why I didn't draw it. So for my lower pulley, I've got FT4 pulling down. I've got F pulling up and F pulling up. Right? Just looking at that lower pulley. FF up, F and F up, and FT4 down. Now looking at my upper pulley, I've got 3 F's down and FT3 up. F, 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 FT3. Okay over there? It sounds like the keyboard's frustrating you. Alright? Good for the free bodies, right? So now mathematically, and I'll do red over here. Over here, all of them I do sum of the forces is MA, right? Because that's my only equation. Here I have FT4 minus MG equals M times 0. Also, FT4 equals MG. So in the problem they ask for, well, FT4, what in terms of MG would it be? So that's kind of like saying, hey, what number would you put in front of MG to equal FT4? One, the number 1, right? Because FT4 equals one group of MGs. Think of MG as a group. Or, well, think about it this way. I used this example in my last class. Think of MG as a $20 bill. If FT4 is 20 bucks, how many $20 bills do you have? 1. Yeah. Okay, that's when they say do it in terms of MG. That's how you should think. Groups of MG. So then, if I look at my center one here, we skipped math. Can someone tell me what equals what in here? F equals FT4, right. And, we could do the math to support that. What about in this last one? That's FT3 up top, by the way. FT3 equals 3F. Good. So if I wanted to know, like, say, in this center one what F was, I could just do a little math and say FT4 over 2 equals F. So give it a try. See if you can, you should be able to, from this point, figure out what answers you need to put into WebAssign. Right? Don't forget that our first supposition on the whole thing, which was all of these F's are exactly the same because they're the same chord. So FT1, FT2, F, all of those are the same force. What? Let's go back to what we were talking about a minute ago. And looking at FT4, you have one group of MG. You told me that, right? So they're asking here for FT4, how many groups of MG do you have? There you go. Now you have a number. You're saying that FT4 equals one group of MG. Yeah. How many groups of MG does F equal? How many groups of MG does F equal? Oh. Sean, if you had $20 and you only had $20 bills, how many would you have? Very good. So let's transfer that. Whenever you see the two letters M and G together, think $20 bill. Okay? So right here, FT says it equals $20. How many $20 bills does it have? One. So how many MGs does it have? Oh, I thought you were being funny. Oh. Either way. Either way works. Okay, so Paris, let's try this question again. No, the answer is
1.
it's not asking, it doesn't ask you how many MGs. It doesn't ask you what MG equals. There's nothing here that says MG equals. It says, how many groups of MG do you have? And for FT4, we said there's one group of MG. Like having one $20 bill. Well, I'm hoping that you can then extend that to figuring out what the other ones are, since I've given you them in terms of each other. Where is 4 coming from? I don't know what you're getting that from. I think we should rename your forces to like Albert, Bob, and George. And because I think you're taking numbers from the names of your forces and putting them in as values. Well, one-third what? MG, one-third MG. For FT3 to be one-third MG, F would have to equal 1/9 MG. Does F equal 1/9 MG? No. Or I could just give you the numbers, you can type them in. And we're kind of at that point. I want to see you try it. And I'll come over and look and point out where your mistake is. Okay? Your next step would be, you know what FT4 is, substitute that in for wherever you see an FT4. And once you've run out of those places, see if you know what F is, and substitute that in anywhere you see F. No. See, no, it's not. Look. Look. Ah, did it. So you're ignoring the MG that's next to that number 1 that you put in. It's a $20 bill. It is. Okay, it's a ducky. It's a rubber ducky. I don't know. I'm trying to think of things that you can think of as groups because you're having a hard time thinking of MG as a group. So $20 bills seem to work for one class. Maybe rubber ducky, bike, book, person. It's a group. It's a thing. So you're saying that FT4 equals 1 rubber ducky. That's what you just typed in the 1 for. See how it has 1 in front of rubber ducky? Okay. Now it's asking you how many rubber duckies does F equal? Okay? That's what it's asking. That's what the next question is. That's what the green here it says. How many rubber duckies does F equal? Well, how many rubber duckies does FT4 equal? 1. So see if you can do them, if you can figure out from this equation here that says F equals FT4 divided by 2, how many rubber duckies F is worth? Ha, good. Good. Now, keep in mind that, how many rubber duckies is F worth? half. So let's go back up here and see that F equals FT1 and FT2. So anywhere it asks you for F, FT1 or FT2, you're going to put in 0.5 rubber duckies, yep. And the rubber ducky part has already been filled in for you. Okay, so let's go back down to our work here. What's FT3 related to? 3F. So what's F again? Half a rubber ducky. Okay? So how many rubber duckies is FT3 worth? 1.5 rubber duckies. No, it'd be 1.5 rubber duckies. Well, let's look. Which force is on the cord here? There you go. See, I knew it was just the mg. If we put it into something you could picture, like rubber duckies, it would work. That's all it is. So